Okay, welcome back to part 4 of the series of lectures on thermal properties. In part 3, I talked about what evaporation is. So in the lecture now, I'm going to talk to you what affects the rate of evaporation. Because evaporation can happen very fast and evaporation can happen also very slow. Usually we know that evaporation happens slow, right? We leave a puddle of water around, and in 1 or 2 days this puddle of water will disappear, and this is because it has evaporated away. Okay, so one definite important factor affecting the rate of evaporation is temperature. So of course, the higher the temperature, the higher the temperature, help me out here, the higher the rate of evaporation. So if I have a body of liquid here and the temperature is, let's say, 19 degrees Celsius compared to another body of liquid, and the surrounding temperature is 36 degrees Celsius. Now all of you know that the rate of flow of energy from the 36 degrees is going to be higher. So therefore, this fella will evaporate faster. Okay? So that's temperature, a bit of common sense there. Now, area of exposed surface. When the surface exposed is large, the greater the surface area, the faster is the rate of evaporation. And again, this makes sense because you guys know that evaporation only takes place at the surface. So if I have this container compared to this container, I have more opportunities for the liquid to evaporate because the surface area is a lot bigger. So the rate of evaporation here is faster. Make sense? Yeah? Humidity. The more humid the surrounding air is, the lower is the rate of evaporation. Now think of it this way. So if I've got a container here with very low humidity, so it's very low humidity, the chances or the space for the liquid to enter into the atmosphere as a gas is higher compared to, let's say, Singapore, where the humidity is like, oh my goodness, the humidity is so high in Singapore, there's literally no space at all for the particles to enter the atmosphere. So that's why with high humidity comes low rate of evaporation. And that's why in Singapore, when we perspire, okay, our perspiration stays on our skin. Whereas in a country of low humidity, okay, you seem to be always very dry. Well, it's not because you don't perspire, but it's because the perspiration that occurs to cool your body down evaporates away very fast. Okay? Motion of air. We all do this on a daily basis. When I have a cup of hot coffee and I want to drink it, what I'll do is that, how am I going to draw big fat lips here? Okay, let's say these are my big fat lips. What I'm going to do is that I'm going to blow the air above the cup of coffee. Now there's a reason why we do this. It's not because of a habit. We do this because this helps the rate of evaporation increase. When we do this, what we are doing is that we are actually creating space above the liquid for the liquid to evaporate away. So when we blow across the surface of a liquid, we are actually increasing the rate of evaporation. So this speeds up the rate of evaporation. Okay? Pressure, the lower the external pressure, the faster the rate of evaporation. Imagine if I've got a container of liquid and there's low pressure, this fella can evaporate away very fast. However, if I got the same container, but now I have a lot of things pushing down on me under pressure, this fellow over here is going to find it hard to evaporate into the atmosphere. Okay, so low pressure, I'll have a faster rate of evaporation. Now, nature of a liquid, I did tell you about the alcohol aerosol spray. So alcohol has a very low boiling point, so that's why it evaporates away very fast. So a liquid with a low boiling point will evaporate away very fast. Okay? Now, the next thing that you have to know is the difference between boiling and evaporation. So boiling and evaporation both involve a change in state between liquid and changes into a gas. Okay? So boiling is generally a fast process, generally, not always, and evaporation is actually a slower process. Okay? Now boiling occurs throughout the liquid. So you can see the boiling process taking place throughout, because you can see the bubbles appearing, okay, as it boils. But evaporation only takes place at the surface. Only at the surface. Whereas boiling takes place throughout the liquid. Okay, from surface only. Boiling occurs at one temperature, that is called the boiling point. Whereas evaporation occurs at all temperatures, the caveat being the substance must be in liquid form. Okay, so you cannot have evaporation occurring for a solid, for example. Okay, now boiling will need a specific source of heat, whereas for evaporation the heat is supplied by its surroundings. So usually when we want to boil stuff, we will need a flame, specific heat source, whereas here it will take the heat from the surroundings. Okay? Boiling, usually bubbles form, whereas evaporation you can't see anything, so nothing visible happens. Okay? So I've come to the end of this chapter on thermal properties. If there's any questions, as usual, please email me at y_H_gene@sass.sg. Alright? So if there are no further questions, if you feel that you are ready to test your knowledge, please go to your workbook. Do 10W1 to, let me see, 10W3. Okay, go and try it out, and we'll go through the answers either face to face or a video call, or I will put up a video with the answers on it. Alright, so for now, see you, have fun, stay safe.